Alright guys, this lesson is on section 1.4, and we're going to talk first about increasing and decreasing behavior in a graph. It says functions can increase or decrease or remain constant over a given interval. The points at which the function changes its increasing or decreasing behavior are called the critical points. So if we have a graph that looks like this, okay, it has some points at which it changes. It was going up. You read increasing and decreasing left to right. It'll be on the next slide. But you go up, hit a maximum, then you go down, hit a min, you go up, hit a max, go down a little bit, hit a min, then it goes up forever. Okay? We're going to describe all that, what's going on. The one thing you need to get from this slide is that those relative maximums, absolute maximums, minimums, okay, all those lumped together are called the extrema. That's just a plural word for all the extreme values. So when you see that in the homework, you're going to go, what's that? All right, here's a nice example of a graph and a slide that tells you that you always do the increasing and decreasing left to right. That's all it is. As I read the graph left to right, what is the value doing? So if I go over here, I'm going up, so that is the increasing portion. You will state this in x intervals, not y values, x values. So from the left hand until it got to -5, it was increasing. This particular graph from -5 over to 0 is constant. And then from 0 to infinity, it's going down or decreasing. See there are notes right here? Everybody get increasing, decreasing? Do you have that slide? Okay, good deal. That one's pretty clear on what it's talking about. This is just a little set to show you quickly that this first graph is only increasing. The second graph is only decreasing. And the third graph at the bottom has a little piece in the middle where it's constant here, from x1 to x2. Okay, otherwise it was all decreasing. All right, so you just got to remember left to right on that. This was an eye-opener for me just because I've always asked this question, am I supposed to use brackets or parentheses? And it says here a function is neither increasing nor decreasing at a particular point. So the point where it changes is not included in the interval. You just use parentheses. Okay? When you're doing these intervals, it's just parentheses. All right. We're going to graph this in our calculator, and we're going to calculate all these maxes and mins, and there's a bunch of them on this graph. Okay? So type that in your calculator, and we're going to find all those maxes and mins. Anybody need help? All right, is a standard window isn't bad, right? It's not great. They have from like -6 to 6. I'm going to actually change my window and change my x values to -5 to 5 a little bit. Leave the y's, I don't really care, but it will just allow me to see that it's a little curvy instead of looking pointy on there. All right, can you start finding the maxes and the mins? I'll start the candy bucket around. How's that sound? Was anybody surprised they found that first maximum? I was. It's not actually on the y-axis, or x-axis, is it? The first maximum here is at, can somebody tell me what they found? Okay. Anybody find this min or this max yet? Did you find that one, Jacob? What do you have?
The max is at 0.4245.
Okay, that's this one over here, right? 0.42 comma, one more time?
Negative 2.4.
And this min? Anybody disagreeing with any of those values? So we had 2 maxes and 2 mins. Relative or absolute? What does that mean? Well, does this graph have an absolute minimum value? It goes down forever, doesn't it, at one end? So it doesn't have an absolute minimum. Does it have an absolute maximum? Can any graph have an absolute? If both ends are going the same way, if they're both going up, then it has an absolute minimum somewhere, right? If both ends are going down, it has an absolute max. Okay. All right, we're going to fill this in. I had too much stuff on my screen here. All right, the correct way to write this is actually like this. There is a relative maximum value of, and give the y value. Somebody give me a y value at one of the maximums. And that occurs at x equals negative 1.49. I'm going to tell you right now, eventually I'm just going to let you write it as an ordered pair and be done with it, okay? Relative minimum, but be prepared on the multiple choice questions. They may state it like this, okay? Relative minimum of, what's the y value at one of the minimums? At x equals negative 0.42. Then we have a maximum that occurs at x equals positive 0.42, and the value is negative 2. Is it? Anybody have more decimals on that one? Negative 2.4? It was 4.4? Okay, thanks. And then one last minimum on the far right. The value was negative 5.91 of the function when x was positive 1.49. Did I get that right? Okay. What did we decide? Does this graph have any absolute value, absolute minimums or maximums? No. Okay. You use those critical points we just found to give the intervals where the graph is increasing or decreasing. And remember, it's x intervals. Okay? So I want the x values starting on the far left. How do I say far left? Negative infinity. What is this graph doing on the far left? Let me get out a highlighter here. It starts out going up. Oh, yeah, that highlighter just made a straight line. Anyway. So it's going up, and then later it goes down, and then it goes up here, and then it goes down, and then it goes up here. Thank you. Those are the increasing pieces, yes? Okay, so tell me the increasing intervals. Good job. Those are the x values, okay? Then where is it increasing again? It is again at 1.49 to infinity, but there was a little stretch in the middle. Okay, everybody get that little stretch right there in the middle? It was also increasing. Okay, decreasing was where? If I pick a different color highlighter like green here, it's going down there and it's going down there, right? So we'd have x values of 0.49 to negative 0.42. Did I get that one right? And then positive 0.42 to positive 1.49. Everybody okay? Can you handle increasing and decreasing in maximums and minimums? Okay. The next thing we're going to discuss is when you have a crazy graph like this, while there are maximums and minimums that are relative, not absolute on this one, there is also a way the graph is bending, okay? The way the graph is bending changes somewhere in here. Do you see what I'm talking about? This direction, what I like to call the sad face, to this direction, what I like to call the happy face. So the graph was sad, 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 happy, 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 somewhere in here, changes back to sad, somewhere over here, it changes back to happy. The issue is to find that your calculator doesn't have a button to find that point where it changes, okay? It is called an inflection point. You need calculus to actually find the inflection point. We are going to estimate, which is everybody's favorite thing because that means Hofbauer can hardly mark it wrong, right? But it needs to be somewhere between this max and this min. Somewhere in here you need to be scrolling along and figuring out where it changes the concavity, it's called. All right, so we're going to go to this slide. Critical points are those points at which it has a tangent line that's vertical or horizontal. Fancy definitions, okay? Basically, the critical points are all the extrema. What did I say that was?
All the extremes.
Okay, the plural, yes, of all the maxes and mins. Good job. And then this new one is a point of inflection is also a critical point. And basically what that does is where the graph changes from being bent up to bent down or bent down to bent up. Okay, so concavity, I'm going to do this. I'm going to say if it's going this way or this way, that's what I call the sad face. That would be a concave down. If it's going this way or this way, that is a concave up or happy little piece of the graph. All right. The inflection point for now is an estimate of where the graph changes the bend. From bending down to up or the other way. Okay, whichever way, up to down, down to up. These inflection points generally occur between maxes and mins. Not always, and I'll show you a picture where they don't. Yes? No. Good question. It's not even in the first few weeks of calculus, otherwise we could try to get to it, but no. But at the same time, I hate to not expose you to the idea of concavity, so that's why we're going to talk about it. All right. I did want to show you a quick graph. If I have a plain old x cubed, okay? I have a plain old x cubed. Does this have a maximum or minimum? No. But does it change its bending direction? Yes. So this has no max or min, but at 0, 0, it changes its concavity, okay? This piece over here was sad. This piece over here is happy, concave up, okay? I just want to talk about that because when I say they normally occur between the maxes and mins, this one doesn't, okay? So there can be places where it changes concavity. All right, real quick, this is a graph that has some absolutes and some relatives because all of the ends are going down, right? So this one would be called a, which one of those is the absolute max? The one on the right. This is the absolute max, and this is the relative max, okay? So really quickly, you don't have this, I don't think, but this graph would have what? What's this one? Relative min and absolute min. Is there one more at the bottom? Nope, that's it. Okay, moving on. Calculus, yeah, we know. Just be really careful. Guys, end behavior of a graph. You know if you have an x to the 4th or an x to the 6th or an x squared, both ends should be going the same way, right? You all know that. If it's a positive number out front, they should both be going up. If it's a negative number out front, both ends should be down. If you have a degree 3 or a degree 5 or something as your highest power, one end's up and one end's down, right? Okay, if it's positive, it's actually this way. If it's a negative, it's the other way. Bottom line, make sure the window you have chosen shows the end behavior, that you can see the end. If you think you're graphing an x to the 5th and you see this, is that the whole graph? No, obviously not. Okay. We're going to do this one example and then we're going to pick one off the homework. But we're going to finish a couple things on the worksheet, and then we're going to pick one off the homework. This is the only one we're going to do out of these first 3 examples. All right, this takes a little while. Deep breath. Type this in your calculator, because then it asks us to do 100 things, or maybe 99. Unfortunately, I'm barely exaggerating. Anybody notice anything when they were typing this in? Highest exponent power was 6. That means both ends should, it's positive, so yes, they should both go up. What else did you notice? Only has even exponent powers. What does that tell you? It is called an even function, but what does that really mean, guys? Perfect. It's going to have y-axis symmetry. We can cheat. Because it has y-axis symmetry, if we find a min that's on the left, should it have the same min on the right? Love it. Okay. I don't know what my window is set at. This isn't too bad. This might be the one that a zoom decimal works pretty good. Trying to remember. Nope, goes down too far. Whoop, 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 whoop. I know what happened. Your x's are -3 to 3. All right, mine's not bad. I'm just going to leave it. I'm being lazy. Okay, let's go, guys. Somebody find mins and maxes while I'm attempting to sketch. My sketch is stinky. Okay, I think this is actually 0, 0, isn't it? Okay? So if this is really an even function or y-axis symmetry, if we find this min, we should also know this min. Anybody find one of them? Yes, what you got, John?
Negative 9.7 is the x, and the y is negative 5.03. Or negative 0.97.
Okay, yeah, thanks. I was like, it doesn't seem that far out. Did I do something wrong? Negative 0.97, okay. Let me try to fix that. Is there a min over there at negative 0.97, negative 5.03? And what do you think this one is over here then? You can find it, but it actually turns out, because of the symmetry, to be a positive 0.97, negative 5.03. It doesn't actually ask us to find the zeros, so we don't have to find those. We just have to find everything else. All right. Before we do anything else, let's try to figure out, are there some inflection points somewhere in here? Now, what you do to find an inflection point is you trace and try to estimate where you think it's changing the bend. The only requirement I have is it needs to be on the graph. You can't randomly say, oh yeah, I'm going to pick negative 5, negative 5. Okay, it's got to be a point that's on the graph. So you need to be tracing. It's not the, you can't just average the x values on the max and the min. If it was, I'd tell you, okay? But it's trickier than that. Is anybody okay with using 0.5, negative 2.09? Does that seem okay? Remember, this is an estimate. You could have a different value. I'm just trying to find one that doesn't seem too hard to write down. So this one over here would be negative 0.5, negative 2.09. All right, I'm going to take this off my screen, and I'm going to list everything they said. It says, we are to include a sketch, state the x values where the maximum and minimum occur. I'm just going to be lazy and go with maxes occur where, guys? 0, 0. Relative or absolute? Relative. Okay. Minimums? They're actually, I guess, both absolute minimums. I'm just going to write minimums. They occur at negative 0.97, negative 5.03, and 0.97, negative 5.03. If we were being fancy, we should have written the minimum value of the function occurs at negative 5.03 when x equals 0.97 or something like that. But I'm okay. You don't have to do that. Okay. Then it says where the graph is increasing or decreasing. Okay, what does it start out doing? As I come from the left. Decreasing. So let's start with that. From negative infinity to what? Remember, x values. Negative 0.97. Then what is it doing? It's x values. Do you see? Because it's from the far left. Absolutely, it is from coming from the top down, but it's the x value. I get confused too. X values, it's the left side, so it's negative infinity over to negative 0.97. Then it's the x values where it's increasing. Anybody help me out? Yep, negative 0.97 to 0. Then it starts doing what? Decreasing again from 0.97. Remember, the inflection points are not where it changes increasing, decreasing. It's where it changes concavity. Last piece, 0.97 to infinity, it's increasing again. All right, what are we missing? Concave up, concave down, inflection points. All right, inflection points we decided were negative 0.5, negative 2.09, and positive 0.5, negative 2.09. Okay, concave up. Again, X intervals. Where's it happy? Happy, happy, happy coming from the left until where? Happy, happy, happy. Oop. Okay. Then it's concave down. This little piece right, I don't know, what color can I use? This little piece right in here is sad. What's that interval? Yep. And then it's happy again from 0.5 to positive infinity, meaning off to the right. All of this. Okay, remember those are all X intervals. Any questions? You do not have to identify concave up and concave down tomorrow. And remember, it's all multiple choice. So while it does have inflection point possibly, it would be given. And you could just scroll along and say, yeah, that seems like a reasonable inflection point to me. Okay? Word problem. The evil box has come back. When we did the box question before, we were cutting out a certain sized corner from an unknown sized sheet of cardboard. What's changing this time? We know the whole side of the cardboard was 18 inches. But we don't know how big the little squares are that we're cutting out. It says a box with no top and a square base is to be made by taking a piece of cardboard, cutting equal sized squares from the corners and folding up the sides. Okay, when we go to fold this into a box, okay, not the worst box, but not the best. I need to know this dimension right in here. It started out as 18. I cut off an X on each corner, so it is 18 minus 2X. Nicely done, John. This is 18 minus 2X. It was a square, so what's this dimension going back this way? 18 minus 2X. Now, how deep is our box? Yes, the squares we cut out to make the depth were X. All right, write a function v of X for the volume. So what's the length of our box? What's the width of our box? And the depth of our box? Okay. If we wanted, when we go to type that in, we might want to type it in as X times 18 minus 2X squared, right? Just to save ourselves some typing. All right, I want to skip the second part. We're going to do that on the calculator. But I want to talk about the relative domain, or the, is that what it's called? Appropriate domain? Anyway. What kind of numbers can X be? Look very carefully down here. How far in can we go if we started with a box that was 18 across? No bigger than 9. Do we all agree? So the domain needs to be from 0 to 9. Now the range is what comes out for the volume. Can you just do me a favor? Put a 2 in here. What's 2 times 2? 18 minus 4? 14. Anybody know 14 times 14?
No, that's adding.
196. So we're around 200. And then if you double it, you'd be around 400. The volume would be around 400 if we cut 2-inch squares. Only reason I do that is because when we go to think about a window, we just figured out that it's going to be pretty big, right? So make your window like 0 to 9 and 0 to, I don't know, I'm going to pick 800. All right, graph this bad boy and see if we can find the maximum volume and the value of x at which that occurs. Let go, stop. Okay, fix, glove undo. Okay, remember the window is appropriate. 0 to 9 and up to like 800 maybe, I'm not sure. Did anybody get a nice little ski slope looking thing there? Okay. Got a bunny hill on one side and something a little steeper on the other. Okay. What do we want to know? The max. Can you find the max in that window for me? And what x did that occur at? Anybody else getting that, or is Jacob too far ahead? Do you guys need help? Is it not working? You good? You sure? Trey, how's all this calculator work going? Good luck on the quiz tomorrow. Okay. So what value of x maximizes the volume? We should cut what? 3-inch squares will maximize the volume. Maximum volume will be what? 432 cubic inches. All right. I'm not going to worry about part C. The relative minimum basically would be 0 if we already talked about the domain. Everybody okay? That's not on the quiz. Does that make you feel better? Okay. We have done average rate of change before, yes? Unfortunately, it was on the homework check. Average rate of change, and a lot of you missed it. Last one. Average rate of change is just what? Anybody remember? Slope. Okay? It is the slope through any 2 points on the graph. It's actually, anybody know what that means, a secant line? A secant is any line that cuts through in 2 distinct points, okay? You're going to find the slope of that line. So, boys are in charge of the first one, girls are in charge of the second. Put a -3 in. Girls, put a -2 in and see what you get out. I'm just trying to make this go faster. What'd you get for the first one? I think I did something wrong when I wrote it down, but it doesn't matter. All right, girls? 1? Okay, what do we do after we find those 2 points? Some of you wrote this down on your homework check. I put a -3, got out 29. I put a -2, got out 1, Miss Hoffbauer. I'm a genius. Okay, it asks for the average rate of change. You're not done. What do you have to do? Yes, you need to find the slope. Y minus y over x minus x in whichever order you want. Anybody else get -28, or did I go too fast and mess something up? We're good? Okay. All right, this time we'll do girls. Get the easy one. And the boys.
Oh, wow. Okay.
Let's see, if I put in a 1, I should get out 1 plus 5 is 6 minus 7 is -1, -5 maybe? If I put in a 3, 27 plus 45 minus 21 is 51 minus 4, 49. Is it right? Is it wrong? 47? Okay, I heard 3 or 4 people say 47, so I'm going with it. Slope. Slope, anybody? Okay, can you remember to do that correctly now on the quiz tomorrow when it asks for rate of change? It's just slope. Okay. Please make sure to change the bottom of your worksheet. It should say you need to do 23 through 29 odd, 35 through 39 odd, and 47. I think that's only 8 problems. The directions are not the directions from the book, though. They are the ones on your worksheet. You need to sketch, give an appropriate window, find all the extrema, maximums and minimums. State the intervals where it's increasing, intervals where it's decreasing, intervals where it's concave up, intervals where it's concave down, inflection points, and end behavior. Okay, pick a problem off the homework. We have 10 minutes.
All of them.
Sounds like a plan, then.
That's a good problem. I like that.
Okay, 23 through 29.
29. 29.
Should I do 27? I haven't done 27 yet today. I'll pick 27. I don't care. There's 27. I'm just picking one. I haven't done that one yet today. Okay, I'm going to stop recording just because it gets too long in the